Okay, today we're going to talk about arithmetic sequences, and to start out, I've got solutions for all of your worksheet problems here on the first couple of pages of these notes. So you can take a look at those if you need any help, and you're still welcome to ask in class. So let's talk about arithmetic sequences today. So an arithmetic sequence is a sequence where the difference between each successive term is always the same amount. The same amount is called a common difference. So if we look here, the difference between these two is 7. The difference between these two is 7. The difference between these two is 7. So it's the same on every example that we have. So we say it's a common difference, and this would be an arithmetic sequence then. This would be the first term, which we would call a sub 1, the second term a sub 2, the third term a sub 3, and the fourth term a sub 4. And then this is an infinite sequence because it does not have an end, it's just got the dot, 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 dot on the end. Okay? The terms of an arithmetic sequence with the first term of a and a common difference of d follow this pattern. A plus D, A plus 2D, A plus 3D. So if we look at this example here, the first term, A, was 15. The second term was 15 plus 7, which came out to be 22. The third term was 15 plus 2 times 7, which would be 29. And then the third term was, or the fourth term was 15 plus 3 times 7, which would be 21 plus 15 would be 36. Okay? All right. So notice that there's always one less d than there is terms. So this is the first term doesn't have a common difference because it's just whatever it is, it's the first term. And then the second one has one common difference, the third one has two common differences, and so on forever. All right, so determine if a sequence is arithmetic. So we're going to look here for a common difference. We've got a 3 between those two, we've got a 3 between those two, we've got a 3 between those two. We can't really tell anything else because we don't know the rest of the numbers, so we would just assume on this one that yes, this is arithmetic. With a common difference of 3. And you might say, too, it also has an initial term of 4. We often abbreviate that, too. We just say that a sub 1 is 4 and that d is 3. Okay? All right, prove that the sequence S sub n equals 6n plus 5 is arithmetic. If it is, find the first term of the common difference. Okay, so proving something is a arithmetic sequence is different from just asking, is this arithmetic? Okay, so in order to prove it, you need to take two consecutive ones at random and show that they have a common difference. So how do you do that? Well, you take the n plus first term and you subtract the nth term. So what does that look like? Well, we would take s sub n plus 1 is the term right after s sub n. So those are consecutive. And so that would be 6 times n plus 1 plus 5. We would take that term and we would subtract s sub n, which is 6n plus 5. Okay? So we would subtract those things. So now the first thing you got to do is you need to distribute the 6 in here. So this is going to be, this is probably not the best way to write this. Let's rewrite this as 6 times n plus 1 plus 5 minus 6n plus 5. And you got to make sure that this is in parentheses, and you got to make sure this is in parentheses because you're subtracting the entire thing. So now we would distribute the 6 in here, and that would be 6n plus 6 plus 5. And then I'm going to distribute the minus sign in here, so this is going to be minus 6n minus 5. And then if it's an arithmetic sequence, all the variables will cancel out. You'll just be left with a number. Okay, so 6n minus 6n, that goes away. 5 minus 5 goes away. I'm left with 6. That's my common difference. So we would say d equals 6, and that implies, that arrow means implies, that s sub n equals 6n plus 5 is a arithmetic sequence. Okay, so I proved it, I found the common difference, and then the last thing it asked me to do is find the initial term, and in order to do that, you just plug in 1. So s sub 1 would be 6 times 1 plus 5, which is 11. So there's the first term. So I found the first term, I found the common difference, and I proved this method right up here is proving that it's an arithmetic sequence. If you really wanted to, instead of taking the n plus first term and subtracting the nth term, you could take the nth term and subtract the n minus 1 term, and it's going to come out the same. Okay, prove that the sequence t sub n is 4 minus n is arithmetic. So this is the same thing we did before. So here's what I would do is I would say, hey, put this on pause, work this out for yourself, and then jump back on here and see if you got the same stuff that I did. Okay, so pause your video, work this out, and then I'll see you in a minute. Okay, so let's prove this. So I'm going to take the n plus first term, which is going to be 4 minus n plus 1, and I'm going to subtract the nth term, which is just 4 minus n. Okay, so in order to do that, I got a minus sign I need to distribute here, and I've got a minus sign that I need to distribute in here. So this is going to be 4 minus n minus 1 minus 4 plus n. So then I combine my like terms, so I got a 4 and a minus 4. I got a negative n and a positive n. So I'm just left with negative 1. So that's a constant, so that means it's my common difference. So we'll say d equals negative 1, which implies it is an arithmetic sequence, and you should write that out. Okay, and there's my d, and then my first term, so t sub 1 would be 4 minus 1, which is 3. So my first term, and sometimes we label that a sub 1. In this case it was t sub 1, so we'll just call it t sub 1. It's 3, and I'm done. All right, the nth term of an arithmetic sequence. So for an arithmetic sequence a sub n whose first term is a and whose common difference is d, the nth term is determined by the formula a sub n equals a plus n minus 1 times d. Okay, you want to know this formula right here. Okay? All right, you want to know that formula. It's going to be all over your test. So now it goes back to, we talked about that back here when we said that, your first term and then the second term had 1 common difference, and your third term had 2 common differences, and your fourth term had 3 common differences. That's what this formula says. Your nth term has n minus 1 common differences plus your first term. So for example, find the 13th term of the arithmetic sequence 2, 6, 10, 14, 18. So a sub 13 is going to equal the first term, which that's 2. So 2 plus n minus 1 is going to be 12 common differences. And if I look here, the common difference is 4 everywhere. So that's 4 right there. And then the 13th term is going to be 48 plus 2 is 50. You can amaze freshmen in the lunchroom with this stuff. They will think you are a mathematical god and they will buy you lunch, okay? So, and it's no different. I can find the 5,000th term, okay? If I want to find a sub 5,000, well, that's just going to be 2 plus 4,999 differences. And I just get out my handy-dandy TI-84 plus C Silver Edition graphing calculator and go 4,999 times 4 plus 2. And I get 19,998. Okay, this is more what you would see on a test rather than this, because this you could just kind of count up really quick. That, you're not going to count it up. You need to calculate it. Okay, finding a recursive formula for an arithmetic sequence. So the 8th term of an arithmetic sequence is 75, and the 20th term is 39. Find the first term and the common difference. Give a recursive formula for the sequence, and what is the nth term of the sequence? Okay, so I got 4 things I got to do here. All right, so the first thing I know is that the 8th term of an arithmetic sequence is 75. So what does that tell me? That tells me that a sub 8 is going to be the first term plus 7 common differences. You know what? I don't need the little one here. I can skip that. Okay. Now, the next thing that I know is that the 20th term is 39. So that tells me a sub 20 is the first term plus 19 common differences. Okay, so, oh, and I know that this is 75, and I know that this is 39. All right, now, I have 2 equations and 2 unknowns, so therefore I can solve this. I would probably do it using elimination, so I would take this equation right here and multiply it all by -1. And I would get negative a minus 7d equals negative 75. And I'd go ahead and add it to this one. And when I do that, the a's are going to go away. I'm going to get 12d is going to be 39 minus 75. That's going to be negative 36. And then I divide by 12. And d is negative 3. So now I know what the common difference is. It's negative 3. Once I have the common difference, I can take that common difference, plug it into one of the original equations, and figure out what a is. So a plus 7 times negative 3 is going to be 75. All right, so a minus 21 is 75. And then add 21 to both sides, and I get 96. So a is 96. All right, so I found the common difference. I found the first term. All right, now I need to give a recursive sequence, or recursive formula. So the recursive formula for the sequence. So the recursive formula is going to be a sub 1 is 96, and then a sub n is going to be a sub n minus 1 minus 3. So it's going to be, here's my first term. My second term will be the first term minus 3, my third term will be the second term minus 3, and so on and so forth. So there's my recursive formula. Okay, what is the nth term of the sequence? So remember that a sub n is going to be a plus n minus 1 common differences. So this would be a sub 1 actually. So a sub 1 is 96 plus n minus 1. The common difference is negative 3. And now I distribute that negative 3 in here, so I get a sub n is going to be 96 minus 3n plus 3, and a sub n is going to be 99 minus 3n. And there you go. So if I want to know the 52nd term, I just plug 52 in here and here, and I figure out what a sub 52 is. All right, so there's 4 things that I did. I found the common difference, I found the first term, I found a recursive formula for the sequence, and I found the nth term of the sequence. All right, next we're going to find the sum of an arithmetic sequence. So let a sub n be an arithmetic sequence with the first term a and a common difference of d. The sum s sub n of the first n terms of a sub n is s sub n is n over 2 times 2a plus n minus 1 times d. I don't really use this formula right here. This is what we're going to use right here. We want to use this one. It's the same thing if you work it out. N over 2 times the first term plus the last term. Okay? So this is on your formula sheet as well. So find the sum s sub n of the first n terms of the sequence of 3n plus 5. That is, find 8 plus 11 plus 14 plus dot 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 plus 3n plus 5. Okay. So the first n terms, the sum of the first n terms, is going to be n over 2 times the first term, which is 8. Okay, and I get that by plugging 1 in here, right? 3 times 1 is 3, plus 5 is 8. Plus the last term. Well, I don't really know the last term on this one because it's an infinite sequence. So I'm going to put 3n plus 5 in here. And then my answer is going to have a variable in it. Okay, so this ends up being 3n plus 13 times n over 2. Okay, and you could just leave it like that. I mean, there's not much more you can do. So if I wanted to find the sum of the first 30 terms, I just put 30 in here, and I get 15 times 90. Here, let's figure it out. S sub 30 would be 30 divided by 2 times 3 times 30 plus 13. So this would be 15 plus 90, or 9 times 90 plus 13, which is 103. So that'd be 15 times 103, which 15 times 103 is 1,545. Okay, let's find the sum of the sequence 12, 17, 22, 27, dot, 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 337. So I'm going to add up all these numbers. The sequence, it starts at 12, has a common difference of 5, and it goes up to 337. So I'm going to find, now I don't know what number n is on this one. S sub n is going to be n over 2 times the first term plus the last term. Okay, so 337 plus 12 is going to be 349. All right, so now in order to answer this question, I got to figure out what n is. So how do I figure out what term it is? I certainly don't want to go 1, 2, 3, 4, all the way up to 337. So here's what I'm going to do. I'm going to take the last term, and I'm going to subtract the first term. And that's going to be 325. Now, what is that? That is the sum of all the common differences. Okay? This is the sum of all the common differences. That's what that is. Okay, now I know the common difference is 5. So if I take this and I divide it by 5, okay, I'm going to get 65. That tells me that there are 65 common differences. Okay? There's going to be 65 common differences, and that means, remember that there's always one more term in the sequence than there is common differences, because the first one doesn't have a common difference. It's all the ones after that. So if I have 65 common differences, I add back the first term. That means there's 66 in the sequence. There's 66 numbers in the sequence. So that tells me that I'm finding S sub 66, and I can go ahead and put 66 in here for n. And now I can figure this thing out really easy. This is 33 times 349. So 33 times 349 is S sub 66 comes out to be 11,517. So I've added up the first 66 numbers in this sequence. Okay, and there you go. So how do I do that again? I use my formula. I plug in my first term and my last term. Then I have to figure out what n is. So I take the last term, I subtract the first term. This gives me the sum of all the common differences. I divide that by the common difference. That tells me how many common differences there are. I add the first initial term, which doesn't have a common difference. That tells me how many numbers are in the sequence. So I'm finding the 66th term. I plug that in for n, and I just work out the answer. Okay. And that, my friends, is that. So here's your worksheet. Okay. So you got 21 problems to do here. And make sure that you make good use of your formula sheet, which I posted to Google Classroom. And I will talk with you later.